So there is another method of factorization of polynomials which is based on mathematical identities. So what are mathematical identities? These are the equations which are true for every value of the variables they have. So whatever value you put for x and y, this equation will always be true. So these type of equations are called mathematical identities. How we use these in factorization? We will get a polynomial in the form which is on the right hand side of this identity. So what this identity is telling us that if some equation is of the form of x square plus 2xy plus y square, so this can be written as x plus y whole square. So this is a perfect square of x plus y. So if you open up this x plus y whole square, means if you multiply x plus y twice, so you will get, first you multiply this x with x and y, so you get x square plus xy. Then you multiply this y with this x and this y, so you get yx plus y square. So these two are essentially the same thing, whether xy or xy. So this equals x square plus 2xy plus y square. So it means if we get an equation in this form, so we can straight away write that equation into x plus y whole square. This is a factored form. This is a product of two terms. So this is a factored form. So in questions, if you can figure out that a polynomial given to you is in the standard form of x plus y whole square, so you can straight away write into this. And this x plus y doesn't matter whether it's a plus b or x plus y. For example, the same identity can be written as a plus b whole square would be equal to a square plus 2ab plus b square. So this doesn't matter whether it's x or y. If there are two variables, so the square of the two variables is always equal to the square of the first variable plus 2 times the first variable, second variable plus the square of the second variable. So this is the way you understand these identities. Because what happens sometime, you will get question in the form of x plus y, and then you can substitute a plus b into those values, and then you can use the identity in the form of a plus b. So this happens all the time. So similarly, we have an identity for difference of squares. This is called difference of squares. But note that there is no identity for sum of squares. There is no formula for x square plus y square. We have only formulas for x square minus y square, x cube plus y cube, and x cube minus y cube. So this is called sum of cubes, the cube of the first variable and the cube of the second variable, because these identities involve square of the terms and cube of the terms. To be able to use these identities, you should also be able to pick the perfect square numbers and the perfect cube numbers. So which numbers are perfect squares and which number are perfect cubes? So starting from 2, 4 is a perfect square and 8 is a perfect cube of 2. So similarly for 3, we have 9 and 27. So whenever you see number 27, you should be able to realize that 27 is the cube of 3. Not only 2, 3, but for square values, I would recommend that up to the value of 20, you should be able to recognize the square values. These are the perfect square. And for cubes, maybe up to 10. You should be able to understand that 64 is the cube of 4, and similarly 5 has a cube of 125, 6 has a cube of 216. So immediately when you see 216, you should realize that this is the cube of 6. So these few numbers you should be able to pick that this is a perfect square or a perfect cube. Otherwise you won't be able to transform your given problem into one of these identities. So it will be difficult for you if you don't realize that this is a cube or this is a square. One more thing which you need in order to solve such question would be that you should understand that x6, for example, can be written as x cube raised to the power square and can also be written as x square raised to the power 3, because power of the power always multiply. So sometimes you have to transform your question in this form from x6 to x cube raised to the power square to be able to use this identity, for example, because this is a difference of square. We don't have any sum of the squares, so we have to use this sometimes. So if there is a situation where you have to modify these exponents, so you should be able to do this. So similarly in fractions, for example, I take one example for a cube value, x cube minus 1 divided by 27. Now you can see that this 27 is a cube of 3. So it means that in order to use one of these identities, for example, this identity is similar to x cube minus cube of something. So this is a cube of 1 divided by 3, 1 by 3. So this can be written as 1 by 3 whole cube. So here we are using one of the index laws, that something divided by something raised to the power cube equals 1 cube divided by 3 cube. So basically we first realize that 1 is a perfect cube, of course, and 3 is a perfect cube of 27 is a perfect cube of 3, and 1 is a perfect cube, and then we transform this into 1 divided by 3 whole cube to be able to use this identity. So then we can realize that this x is our first variable and 1 divided by 3 is our second variable. So then we can put in this equation and we can factor this polynomial. When using these identities, you will always be going from right side to left side. So you will get an equation, one of these forms, and you will transform it into a factored form, because all these left hand side is a factored form of these equations. Because all this left hand side are the factored form, and you can say that the right hand side are like open brackets. So this is the open bracket form and the left hand side is a factored form. So now we'll do few examples of each of these cases, so you will better understand how to use these mathematical identities to factorize the polynomials.